The mysterious planet Mars is the fourth planet from the Sun as well as the second smallest planet after Mercury. It gets its nickname the Red Planet and its color from iron oxide prevalent on its surface. Mars has been explored for decades, and there are at present 8 spacecrafts being used to investigate it. 6 spacecrafts are orbiting Mars while 2 are present on its surface. The Curiosity rover and InSight lander are equipped with cameras that capture what's happening on its surface. Both Curiosity and InSight have also taken images of many unusual things on the Red Planet. Keep watching to see what unique discoveries have been made on planet Mars. Olympus Mons is a very large sealed volcano on Mars. It is about 370 miles wide and has a height of nearly 14 miles or 72,000 feet. It is about 2.5 times Mount Everest's height above sea level. Olympus Mons is one of the largest volcanoes, the tallest planetary mountain, and the second tallest mountain currently discovered in the solar system. A series of finely layered deposits on its floor at Holden crater. The layered deposits are especially well exposed in the southwestern section of the crater where erosion by water flowing through a breach in the crater rim created spectacular outcrops. A 1.5 km wide impact crater in the Meridiani Planum region. Changing seasonal frost patterns on Louth crater. Polygons are of great interest because they often indicate the presence of shallow ice or of desiccation such as in a mudflat. However, these polygons originated as wind-blown dunes and formed by the intersecting ridges of sand dunes. A high-rise image of Victoria crater captured by Mars Reconnaissance Orbiter. A crater called Santa Maria which has a diameter about the length of a football field. A view of a promontory called Cape Saint Mary. Dark dunes and sand streaks composed of basaltic sand have moved and filled lower areas pushed by recent winds from the top towards the bottom of this image in a region called Lobo Vallis. An outcrop of crust-bedded sandstone on the lower slope of Mount Sharp. A view from Curiosity rover shows drilling of a test hole and a sample collection hole in a rock, which produce the mounds of drill cuttings that are less rugged than the other visible surfaces. Dark slope streaks like the ones seen in this image are narrow avalanche-like features common on dust-covered slopes in the equatorial regions of Mars. They form in relatively steep terrain such as along escarpments and crater walls. A network of two-tone mineral veins which combine light and dark material. Mineral veins such as these form when fluids move through fractured rocks, depositing minerals in the fractures and affecting chemistry of the surrounding rock. In this case, the veins have been more resistant to erosion than the surrounding host rock. A close-up of the same two-tone mineral vein. Martian sand disturbed by Curiosity's wheel exposed interior material of the sand body, including finer sand grains than on the undisturbed surface. Every Martian spring, fans of dust are blown out from under the seasonal layer of carbon dioxide ice that forms a polar cap over the winter. Gas blowing out from under the ice carries with it a load of dust that is deposited on the surface in a direction determined by the wind at the time of the eruption. This is Opportunity rover at Endurance crater. Sandstones in this image have a knobbly texture due to nodules apparently more resistant to erosion than the host rock, in which some are still embedded. The geologic history of a planet is written in its layers. Erosion of the surface reveals several series of light tone layers, likely sedimentary deposits as seen in this image. The most recent geologic features are the narrow sand dunes snaking across the top of all the rocks. A dark mound called Ireson Hill is seen here, which rises about 16 feet above red layered outcrop material on lower Mount Sharp. The landscape in this image includes the rocky landmark nicknamed Knock Farrell Hill, which is at the center right, and the edge of Vera Rubin Ridge, which runs along the top of the scene. The wonders of time and erosion are on full display in this image of layered hills and dunes in Arabia Terra. Shown in this image are alluvial fans, fan-shaped deposits emerging from regions of steep topography. Alluvial fans on Mars are thought to be ancient and record past episodes of flowing water. This image shows part of one of those fans which has been eroded. Blocks of layered terrain within the Olympus Mons aureole. The aureole is a giant apron of chaotic material around the volcano, perhaps formed by enormous landslides off the flanks of the giant volcano. These blocks of layered material have been eroded by the wind into the scenic landscape we see here. One of the most actively changing areas on Mars are the steep edges of the North Polar layered deposits. This image shows many new ice blocks compared to an earlier image from 2006, which is not as sharp as this one. This image of an exposed section of the North Polar layer deposits is made up of water, ice, and dust particles stacked one on top of the other. The layers are topped with seasonal carbon dioxide frost, as seen here as lingering frost adhering to one of the layers. Here in these side-by-side movies, you can see how a global dust storm covered the red planet, which caused NASA's Opportunity rover to lose contact with Earth. Resembling a dragon, this image shows part of a canyon floor and wall rock in southwestern Melos Chasma. Small valleys can be seen along the wall rock to the south, which is a mixture of two geologic units with differing reflectance. Gullies on Martian sand dunes like these in Meteor crater have been very active, with many flows in the last 10 years. The flows typically occur when seasonal frost is present, which occurs during the Martian southern hemisphere winter. It is believed to be related to carbon dioxide frost that forms as the area grows colder. A close-up of a trough along with channels draining into the depression. On the floor of the trough is some grooved material that we typically see in middle latitude regions where there has been glacial flow. These depressions with concentric troughs exist elsewhere on Mars, and their origins remain a matter of debate. Small sand ripples about 10 meters apart located in Herdesser valleys. Herdesser is a small channel that shows evidence of phyllosilicates, silicates with a sheet-like structure such as clay minerals. During wintertime at the south pole of Mars, carbon dioxide ice caps cover the region, and as the sun returns in the spring, spider-like shapes as seen in this image begin to emerge from the landscape. This is a location called Teal Ridge, captured by Curiosity rover. A hillside view showing sloping buttes and layered outcrops within the Murray Buttes region. The yellow-white cloud in the bottom center of this image is a Mars dust tower, a concentrated cloud of dust that can be lofted dozens of miles above the surface. The blue-white plumes are water vapor clouds. Block Island, the largest meteorite yet found on Mars. Different types of rocks and meteorites on Martian surface. bed of Earth-like pebbles on Mars, which are a good indicator that water once flowed on Mars. This is whale rock, and wind has eroded its thinly bedded rock into incredibly thin plates. Another iron meteorite called Lebanon. Lebanon is about 7 feet wide left to right from this angle. The smaller piece in the foreground is called Lebanon B. In this image, many sand dunes are visible. They have an elongated crescent form and are called Barkan dunes. They are formed by the continuous action of the wind blowing in the same direction. Spectacular buttes and layered sandstone in the Murray Buttes region. Details of an impact crater named Fram. Sand dunes cover much of this terrain, which has large boulders lying on flat areas between the dunes. During late winter in the southern hemisphere of Mars, these dunes get enough sunlight to start defrosting their seasonal cover of carbon dioxide. Spots form where pressurized carbon dioxide gas escapes to the surface. Much of Mars' surface is covered by fine-grained materials that hide the bedrock. But elsewhere, such as in this scene, the bedrock is well exposed, except where covered by sand dunes. Observations of this region of the Noctis labyrinthus formation have shown indications of iron-bearing sulfates and phyllosilicate clay minerals. Sand dunes in the North Polar region showing light coatings of pale orange dust blown partially across the dark basaltic sand. Around the edges of the dunes, patches of seasonal dry ice remain. On Mars, as on Earth, dust devils are whirlwinds that result from sunshine warming the ground, prompting convective rising of air that has gained heat from the ground. Observations of Martian dust devils provide information about the wind directions and interaction between the surface and the atmosphere. An exotic landscape at the South Pole where the polar cap is made from carbon dioxide or dry ice, which does not occur naturally on Earth. The circular pits are holes in this dry ice layer that expand by a few meters each Martian year. Mount Sharp, also known as Ilus Mons, is a mountain on Mars with a height of 18,000 feet. A view of the downwind face of Namib Dune on Mars, including a portion of Mount Sharp on the horizon. A view toward Vera-Rubin Ridge on Mount Sharp. This view from the Curiosity rover shows an outcrop with finely layered rocks within the Murray Buttes region on lower Mount Sharp. The buttes and mesas rising above the surface in this area are eroded remnants of ancient sandstone that originated when winds deposited sand after lower Mount Sharp had formed. Another view of sloping buttes and layered outcrops within the Murray Buttes region. A boulder-sized rock called Strathodon, which is made up of many complex layers. This is Jupiter as seen from Mars. A rock outcrop called Misoula. some more layered rocks within the Murray Buttes region. A hillside outcrop within the Murray Buttes region. A view of the Kimberley Formation in Gale Crater, which shows many sedimentary rocks. Panorama of the rim of Erebus Crater. Another view of Mount Sharp. An image of the Martian mineral deposit that scientists now think may have been created by volcanic eruptions as seen from orbit. This video shows clouds drifting over dome-covered seismometer known as SEIS belonging to NASA's InSight lander on Mars. Viscous lobate flow features as seen in this image are commonly found at the bases of slopes in the mid-latitudes of Mars and are often associated with gullies. The dashes seen in this image are linear dunes formed by bidirectional winds which are not traveling parallel to the dune. Instead, the combined effect of winds from two directions at right angles to the dunes funnels material into a linear shape. The smaller dots called Barkanoid dunes occur when there is some interruption to the process forming those linear dunes. The twisting dark trails crisscrossing light-colored terrain on the Martian surface are the work of Martian dust devils. Typically lasting only a few minutes, dust devils become visible as they pick up loose red-colored dust, leaving the darker and heavier sand beneath intact. In this image, we see a set of straight ridges in ancient bedrock near Nergal valleys. The patterns indicate fractures from tectonic stresses. Sedimentary rocks and sand within Danielson crater, an impact crater about 42 miles in diameter. Maria's Pass, an area where a lower and older geological unit of mudstone, the pale zone in the center of this image, lies in contact with an overlying geological unit of sandstone. Cape St. Vincent, one of the many promontories that jut out of the walls of Victoria Crater. This rock called Hata is a combination of small rounded pebbles and sand bonded together to form something that looks like a slab of concrete. The roundness of the pebbles implies these were transported by fast-moving water. In other words, this is evidence for rivers having existed on Mars. A rock called Bathurst Inlet. Rocks near Gusev crater. A view of Gale crater, a probable dry lake on Mars. It is 96 miles in diameter and estimated to be about 3.5 to 3.8 billion years old. The largest canyon in the solar system cuts a wide swath across the face of Mars. Named Valles Marineris, the Grand Valley extends over 3,000 kilometers long, spans as much as 600 kilometers across, and delves as much as 8 kilometers deep. They might look like trees on Mars, but they are not. They are groups of dark brown streaks on melting pinkish sand dunes covered with light frost near the North Pole of Mars. Image of this impact crater shows a couple of dark lineations on the equator-facing wall that resemble small recurring slope lineae. However, unlike typical recurring slope lineae, these lines persist for several Mars years with only minor changes. Alternating layers of ice and sand in an area where they are exposed on the surface of Mars. Water ice is seen here as light-colored layers and sand as darker layers of blue. The tiny bright white flakes are thin patches of frost. One of the unsolved mysteries on Mars, this surface texture of interconnected ridges and troughs, referred to as brain terrain, is found throughout the mid-latitude regions of Mars. A Martian avalanche. Curiosity rover imaged these drifting clouds using its navigation cameras. Curiosity rover's view of Mars sky at sunset. Curiosity rover taking a selfie before climbing the rock layer called the Green Hue Pediment. These BB-sized spherules or blueberries are found all over Meridiani Planum, landing site of Opportunity rover. These are packed with hematite, a mineral that supports the case of water in Mars past. But their composition still does not answer the question of whether the Martian water once existed as a lake or was solely locked up in the form of groundwater. A panorama of Greeley Heaven outcrop. This is Phobos as it crossed in front of the Sun. This is Deimos as it crossed in front of the Sun as seen by NASA's Curiosity Mars rover. Hundreds of individual lava flows are seen frozen in time on the flanks of Olympus Mons, the largest volcano in the solar system. These giant honeycomb-looking intersecting shapes or polygons commonly occur in the northern lowlands of Mars. The polygons in this pattern ground are easy to see because their edges are bound by troughs or ridges covered by bright frost relative to their darker frost-free interiors. Recurring slope lines are seasonal flows on warm slopes and are especially common in central and eastern Valles Marineris as seen in this observation by Mars Reconnaissance Orbiter. Sand dunes on Mars during springtime in the northern hemisphere. Streaks forming on Martian slopes when dust flows downhill. This observation shows relatively bright mounds scattered throughout darker and diverse surfaces in Chryse Planitia. These mounds are hundreds of meters in size. The largest of the mounds shows a central pit similar to the collapsed craters found at the summit of some volcanoes on Earth. The origins of these pitted mounds are uncertain. They could be the result of the interaction of lava and water or perhaps formed from the eruption of hot mud originating from beneath the surface. Sand dunes often accumulate in the floors of craters. In this region of Lyot crater, NASA's Mars Reconnaissance Orbiter shows a field of classic Barkan dunes. Just to the south of the group of Barkan dunes is one large dune with a more complex structure. This particular dune, appearing blue in enhanced color, is made of finer material and/or has a different composition than the surrounding. A view across Endeavour crater. NASA says cross-bedding in the layers of this Martian rock is proof that water moved on Mars, leaving waves of ripples on loose sediment. A panorama of the Martian surface. Inside lander moving its robotic arm closer to its digging device called the mole in preparation to push on its top or back cap. The mini pile driver is designed to hammer itself as much as 16 feet down. The pushing down on the mole's top, also called the back cap, will keep it from backing out of its hole on Mars. Curiosity took this photo of a target named Ronan at the base of Stimson unit. It contains rounded grains with a wide variety of colors. A rock fragment dubbed Lamuse, which has unusually high concentrations of silica. Here you can see the mole digging about half an inch below the surface using a technique called pinning. A panorama of the Nathan Bridges Dune. Layers of rocks at the edge of Hidden Valley. Another view of Victoria crater, which is roughly 730 meters wide. At around 2200 kilometers in diameter, Hellas Planitia is the largest visible impact basin in the solar system and hosts the lowest elevations on Mars' surface as well as a variety of landscapes. This is an impact crater that triggered a slope streak. When the meteoroid hit the surface and exploded to make the crater, it also destabilized the slope and initiated this avalanche. Honeycomb pattern dunes in Olympia Undae, a dune field in the north polar region of Mars. Liquid water has been discovered beneath Mars' south polar ice cap, raising intriguing possibilities for both astrobiology and studies of Mars' past climate. Dunes of sand-sized materials have been trapped on the floors of many Martian craters. This is one example from a crater in Noakis Terra. Acidalia planitia, which is seen in this image, is part of the northern plains of Mars, at a latitude of 44 degrees north. Although there are impact craters in this area, some of the features, like in the lower center of the cutout, are too irregular to be relic impact craters or river channels. One possibility is that the sedimentary layers have been warped from below to create these patterns. This is Moru crater. Mars between day and night, with an area containing Gale crater beginning to catch the morning light. This is Phobos in orbit around Mars.
Thanks for watching and don't forget to like, share and subscribe.